Have you ever wondered how a web server container actually talks to a database container, or why some containers can ping each other while others seem completely invisible? And here's the interesting part from the host. You can ping every container, but containers themselves can't always do that. In this video, I'm going to walk you through all of this using simple hands-on examples. Welcome back to my channel. I'm Phương, and this is my practical, no nonsense Docker and DevOps series designed to be easy to understand and instantly applicable. Today, we are diving into Docker container networking, one of the most important topics when working with microservices. Okay, let's get started. Let's start by looking at the networks Docker gives us right out of the box. Docker Network OS. You notice a few default networks here, but the most important one is bridge. If you don't specify a network, Docker push your containers here automatically. Now let's spin up an Apache container named Web1. Docker run with option D, name Web1, HTTP D, 2.4. Enter Docker is part Web1. Okay, when you impacted Docker assigns Web1 an IP address inside the Docker 0 bridge, typically something in the 172.17 range. Next, let's run a temporary BusyBox container to test connectivity. Docker run with option R, M, IT, BusyBox. Enter inside BusyBox. First, check the IP address of this container. IP address. Okay. Now try pinging Web1 using its IP address. Ping. Enter. Okay. This works. No surprise there. Now pinging it by hostname. Web1, and this time it fails. That's because the default bridge network doesn't provide DNS resolution between containers. To fill it up, let's try accessing the server using wget. wget. Okay, and then exit BusyBox. Exit. Okay, in the default bridge network, containers can talk to each other using IP addresses, but not by name. However, here's the key thing to remember: the host can reach all containers because Docker manage all those networks at the host level. Okay, now let's create a custom bridge network. And in this network, containers can resolve each other by name. Docker network create test application. Enter. Next, let's run web2 and attach it to test application. Web2 network test application. Enter. Okay. Docker is by web2. Okay. You see that Docker gives it an IP inside this new network, starting with BusyBox in the same network. Network test application BusyBox. Enter. OK. IP address. Enter. OK. Now ping web2 using its IP. OK. And now ping it by name. Ping web2. OK. This time it works because custom bridge networks come with Docker DNS built in. Let's also test using wget. Wget web2. Enter. OK. Now let's try pinging web1, which is still sitting in the default bridge network. Ping. OK. Ping web1 wget web1, and as awaited this fails because different Docker bridge networks are fully isolated from each other. Now exit BusyBox. Okay. Now let's look at a completely different networking mode. In the host network, the container shares the host network stack, so it doesn't get its own private IP. Enter. Okay. You can test this immediately from the host machine itself. Wget localhost. Okay. Now stop the container and test again, Docker stop web3. It fails as expected. Okay, starting web3 again. Start web3. Okay, now let's run BusyBox again, but this time also using the host network. Docker run rm it network host BusyBox. Okay, inside BusyBox, try accessing localhost wget localhost. Okay, and now try pinging the containers in the bridge networks. Ping 172.17.02. Okay, web 2. Okay, and you see the succeed because when BusyBox uses the host network, it effectively becomes the host, and the host can reach every container across all Docker networks. If this video helped clarify Docker networking for you, go ahead and hit like to support the channel, subscribe and turn on notifications so you don't miss future videos on Docker, Linux, and DevOps. Thanks for watching and I'll see you in the next video. Okay?